Okay, so here we are back to the VCAA 2021 Maths Methods Exam 2 for the multiple choice section. We're up to question 6 here. All right, so probability of winning a game is 0.25. Probability of winning is independent. If Ben plays 10 games, it's the probability he will win exactly 4 times. All right, so we have therefore a binomial because we've got two options, a win or a lose, and they're independent of each other. So let's have a look at our calculator, because we can do this on our calculator because n is 10. Probability of success or winning is 0.25, and the number of times we want to win exactly 4. So we'll go to our calculator. So this is the Casio one. So go to our calculator, and we're going to the interactive menu, going down to the distribution, and we've got discrete, and we want binomial PDF. And so what's x? X is 4. And the number of trials we've got is 10. And our probability of success there is 0.25. And okay, so 0.14599. So 1.14599. 14599. So we're looking for the one that's closest to that. And there it is there. A. All right, question 7. The tangent to a particular graph passes through the origin. So the tangent passes through the origin. The value of A is. All right, so what have we got? So the tangent, we know. What do we know about the tangent? Well, we know that the tangent's got to have a gradient. And so the graph, the gradient is dy dx, which is 2x squared minus 2ax. All right, at x equals 1. So at x equals 1, the gradient of that graph would be 2 times 1 squared minus 2a times 1, which is 2 minus 3 x squared, not 2x squared from that first term. Sorry about that. All right, so here's our gradient. So our point here, we've got our tangent, and we've got our gradient of our tangent, and we know it passes through the origin. So this graph of whatever it looks like, I don't know, no, that doesn't look anything like that. But it goes through some point. So at x equals 1, so x equals 1, y equals, what does y equal? Well, 1 cubed minus a times 1 squared plus 1. And when we get that, that's 2 minus a. 1 plus 1 is 2 minus a. So the point that we're looking at this gradient, this tangent being at, is the point 1 and 2 minus a. And what we know is that this tangent goes through the origin, which is down here, it goes through the origin. So it goes through 0, 0. Now, what else do we know? Is we know that the gradient of this tangent is that there. So the gradient of this line is 3 minus 2a. So gradient is 3 minus 2a. But also the gradient is the rise over the run. Now the rise and the run, we know them as well because we know that's the origin and we know what that point, and the rise is 2 minus a, and the run is our x value there over 1. All right, and so then we've got 3 minus 2a is 2 minus a, and then we rearrange things and we find that a is 1. All right. All right, so the key thing here is that we know that the tangent passes through the origin. We know where the point from the tangent is because it's at x equals 1. So we equate the gradient of the tangent from the derivative to the gradient of the line joining those points, which is, of course, part of the tangent. All right, that's question 7. Question 8 would be the next one. Scroll down to 8. The graph of that function here, the graph corresponding to the derivative. All right, so graph corresponding to the derivative. So the derivative graph relates to our gradient. All right, so what's happening? Here, our gradient is tending towards 0, but it's positive. All right, so it's a positive gradient. Why is it positive? All right, because it's going up left to right. Down this end here, the gradient is big. All right, so, infinite if you like. And of course it's positive. All right, so the whole time the gradient is positive, so the whole time we've got graphs in the positive area. So that cuts out C because that's down here negative y, cuts out D because we've got a bit here down in the negative y. All right, what else have we got here? The other thing is it's only to the right hand side of this A. So that cuts B out. Oops, B out because that's the left hand side of A. So which is the only one that's to the right hand side of A? E. So E is our answer because close to A it's a big number. Further away from A, as x getting bigger, it's getting smaller towards 0. All right, so that leaves this one here. This one here actually looks like the inverse, not the gradient, the inverse graph, not the gradient graph. Just a bit of extra information. And remember, all of these graphs here are what the gradient is, so anything which is down underneath, like these two, represent a negative gradient. Okay, excuse me, number 9. Number 9, let G be x plus 1 and f be x squared minus 4. So we've got a composite function h, and h is f of g of x. Then the range of h is. All right, so let's have a look at f of g of x first of all. So f of g of x means you put the function g of x into f for x. So the function g of x is that, and that goes in here for x. So it's x plus 2 squared minus 4. And then what I am suggesting is that you then get your calculator out, you graph it on your calculator, you set your domain, and you have a look. And when you do that, what you get is a graph that looks like this. So we are after the range. So what we want to know is this highest point here. And when you use your calculator to find that out, you find that that's that. And we want to then know the lowest point. And when you use your calculator to find that's at -3, -4. So our range is these ones from -4 to 5. And it's E. Why is it? Because this point's included. This point up the end here relates to our -5. Now, when you look at the bracket next to the -5, it's a square bracket, so it's included. So this end here is not included. That end is included. And of course, this point, which is our lowest point, is also included because it's within the x values within that particular domain. All right, so there's E, so that's why it's E and not D. All right, question 10. Consider these two functions. Find over their maximal domains, the maximal domain of H, which is this time F plus G. All right, so when we have a look at the domains of F and G, so the domain of F, so a domain of f of x, when we have a look at this, this is square root. Can't square root negatives, but you can square root 0. So that one's going to be okay from -2 up for x. All right. Domain of G, again, that's got to be positive. And so this time, when we have a look at that, well, 0 when x is a half. Because 2 times a half is 1, 1 minus 1 is 0, so that's okay. All right, now with this one, we've actually got to go this way here. How do I know we've got to go this way here? Well, say, for example, x equals 0. 2 times 0 is 0, 1 minus 0 is 1, square root of 1, that's okay. So we're going down, all right, because it's been reflected. All right, so F plus G. So our domain of F plus G, that's when we've got to add these things together. Now we can only add them together where each individually exists. So like up here, for example, we've got some value from fx, but we don't have any value that exists from g. So f plus g is not going to exist up here. Similar down here. But for the opposite reason, g exists, but f doesn't. So it's only between -2 and a half. And both of those are included. And so that is what we are looking at. Why are they both included? Because this endpoint's included, this endpoint's included. All right, implied domain, 0, can square root 0, so that point's okay. And of course, when you look at, it's also included in the opposite graph. All right, so that's why it is D. All right, so there we go for that group of questions. More videos for the other groups of questions.